Hey, good morning, everyone, or maybe I should say almost good afternoon. So I'm a staff machine learning engineer at Credit Karma, which is a part of Intuit now. I'm accompanied by my colleague Sukanya Moorthy. So basically, today we are going to talk about our Credit Karma's financial assistant, which is powered by Kubernetes, right? And specifically highlight one solution, which in this particular umbrella, they call the CY solution. So this solution is powered by LLMs and Kubernetes both together. I want to specifically highlight how in this solution, the overall journey of creation, how we have used Kubernetes from end to end. So this is the main thing to highlight is basically this is a real use case. It's not theoretical per se. This is actually live and serving around 140 million plus members of Credit Karma. So just to set the stage, then this is the agenda we have today. So I just want to introduce what Credit Karma is and what we do, and give you the context for Credit Karma, and then briefly talk about the CY solution, right, and what we are trying to do by this particular solution and how it is helping our members per se, and then talk about Kubernetes, our ML lifecycle on Kubernetes and how it evolved to actually take care of or accommodate this particular solution, and at the end leave you guys with what lessons we have learned, and probably it will trigger some food for thought overall after that, right? So now coming to Credit Karma, our mission is to champion financial progress for all, and our vision is that we want to be a comprehensive, self-driving financial platform that propels our members forward wherever they are on their financial journey, right? So, and how do we do that? With the help of a bunch of tools which we provide on the platform. So we go beyond credit scores to give members the tools and confidence to take over their financial life. So every product, so the main thing is every product we build is designed to deliver clear value and put members in control of their financial journey. So like example, I see like all these tools you see, right? Money management, marketplaces for cards, loans, and credit building tools, and Credit Karma Money where you can spend, save, everything, right? So all of these are meant for with the only purpose to help members make smarter money moves every day. So last three slides, I talked about financial journey, right? I just want to throw some light on it. Like, what do I mean by financial journey? So basically navigating your finances or managing your money, it looks like it's a one-line statement, but it's actually very complex problem when you sit down or when a member actually starts doing it, right? So they're bombarded with a lot of questions that, hey, am I at this point in time on the right track managing my finances? So how can I improve my credit score faster? And if I'm actually looking at a card or if I'm actually looking at any loan product, right? So you see a lot of numbers in it, like what's APR, rewards, fees, etc. What do they actually mean? So, and am I missing out on any financial product per se? So what we strive on doing is basically we want to empower all our 140 million members with personalized insights based on the data and ML at scale to actually answer these questions via tools and via whatever solutions we provide, so that members can make informed choices throughout their financial journey, right? So one such solution is CY solution, right? So before I go there, before I talk about, I just want to introduce that problem and solution. And before I actually do that, I just want to lay out the core principles using which technically how we build a solution, right? So we want to leverage your data as much as possible, which leverage members' data, which they have entrusted Credit Karma with, and feed them to Intuit's advanced AI and ML algorithms and get powerful insights out of it. And all of this, we want these solutions to be built for reliability. We don't want any downtimes or anything. So that all of our 140 million members actually get access to these solutions without seamlessly. And That being said, we want to have these solutions be secure and private. So we want to put this security and security at the paramount step altogether, right? So now that I have laid out that principles, I just want to give you what the CY solution is, right? So when I was talking about financial journey, I was talking about questions. One such question is like example, if Credit Karma is recommending a card, let's say, right? So when you look at it, one such question is, hey, why is Credit Karma recommending this particular card to me? So that question itself is very loaded. So there are a number of other questions alongside it, like, hey, out of so many cards you have, like, why are you recommending this particular card to me? Right? And what do these complex numbers inside those mean actually? So rewards, APR, fees, benefits, and what do they actually mean? And does this actually fit my financial situation right now? And does it fit my spending habits? So we need a solution which can answer these, like, in a personalized fashion. If you see the right side two, pictures, it's actually live. So basically, whenever we are recommending something, if you click on CY, you would see a complete explanation, a personalized explanation on why we are doing this, right? And we want to do this, the solution is, what we do is basically the solution analyzes your financial data, like your whole complete credit profile, and explains the card's benefits and explain why we think that, okay, hey, this particular card is actually the right fit for you at this point in time, right? So by doing that, what's the result? Basically, members can now make a more informed decision about, if they want to take this card or not. So we are empowering, the members to do the right thing for them at that point in time, right? So overall, this particular solution is now live in on iOS, Android, and web. So one of the things which I want to establish is basically that, okay, this solution is powered by LLM and also Kubernetes, right? So now, in general, whenever you're trying to do, use LLM for any commercial product, right? It's a well-documented problem that there are a lot of challenges associated with it. So I have added a QR code which gives you a extensive list of what all problems you actually see. This is very well-known problem in open source realm. So if you are trying to use LLM to generate any user-facing content, right? So you have problems like safety concerns, privacy concerns, compliance issues, experience issues. You want to protect your brand. There are brand protection issues. There are like N number of things which come with it. Like example, you don't want to be sending any toxic content to, or angry content to LLM, because it easily translates to the response also in a similar fashion, and you don't want to show that to the members, right? It's not good experience overall. So in a similar fashion, so basically, so there is a need for a safety layer before you are sending any requests to the LLMs, and also there is a need for a safety layer after you get a response from the LLMs. So you need these safety layers act as your guardrails before you surface any content to the user. So I'll talk about these safety layers in the next two slides per se. So whenever you're sending any, so these are, I have laid down few examples for you, these are well documented in a bunch of references, which you can see down in the slide. So basically, what you want to do is you want to detect things like toxicity, profanity, anger, and you want to filter them out before, and then you want to restructure your particular question which you are giving to LLM before you send it to, before you send the request to LLM, right? So similar, and mainly for us, the main strategic goals on how we create these guardrails are, the deciding points are these 4 points. Like, we want to protect our brand, we want to be compliant, we want to ensure that, okay, hey, we are not going over any regulatory requirements. We want to make sure that members get the right experience because we want to route the conversations intelligently based on the intent on which this is being operating on, and then we want to add a lot of safety layers and guardrails on top of it, right? So so in a similar fashion, you have we have strategic goals for creating output guardrails as well. So there we want to ensure that, okay, hey, whatever responses you are getting from LLMs, they are hallucination free. You don't want them to give random outputs and take them in 10 different places. And you don't want to have any links showing up. So you don't want LLMs to have any sentiment or bad sentiment as well. So you want to make sure with these strategic goals, we have built a bunch of guardrails. And I have documented how industry and the open source is actually tackling this problem in a bunch of references in this particular. If you look at that QR code, you will see all that, all those things. So overall, the point is that there is a need for a lot of guardrails, both before and after the LLM calls per se. And these guardrails are evolving extensively and in a very fast manner in the open source world. And these guardrails are built on lots of diverse set of frameworks. So a lot of them are TensorFlow friendly, a lot of them are Torch friendly, JAX friendly. So overall, to actually productionize these and build on top of anything available on open source, it's a challenge, but we could do it, but it didn't happen overnight. So I'm going to hand it over to Sukanya to actually talk about that particular journey of how we started off and then later evolved so that we could accommodate this and make it happen. Yeah.
Thank you, Raj, for the overview on the guardrail structure. So like Raj mentioned, we ended up in a place where we needed a lot of guardrails, and we were in a place where we needed them to be model agnostic and framework agnostic. So how did Kubernetes come into the picture for us is to be able to bring in this agnostic fashion of moving fast on how guardrails change. So given this perspective, we wanted to evolve our MLOps lifecycle according to the needs of the guardrails. And guardrails are specifically models for us. So guardrails involve the model training cycle and model serving component. And here is lay of the land on the complete ML lifecycle with Kubernetes to support these guardrails. So for the training, we utilize Kubeflow heavily, and every different component of training, like data collection, data pre-processing, model training at scale, evaluation and export, each of these components, we relied on Kubeflow to make them agnostic. And coming to, once we have a model trained, like a guardrail model, which is available offline, now we move on to the serving side of the component. And with respect to serving, we were able to also utilize Kubernetes patterns and make it framework agnostic as well as cloud agnostic. So by utilizing Kubernetes heavily, we were able to quickly move fast in the ever-changing landscape of guardrails. And overall, apart from these, apart from training and serving, we also have monitoring component, which kind of bridges the gap for us on with evaluating all the model predictions and also giving us a sneak peek into the offline and online world. So one of the interesting aspects, apart from the traditional ML lifecycle, which we all know about, like training, serving, and monitoring, is RAG workflow. So we see RAG as an extension of model training component. So RAG has different components, such as you have your content extraction flow, and then you have your embedding generation and index creation flow. So we were able to utilize and extend our model training Kubeflow patterns with RAG pipelines as well. So given this lay of the land, now any data scientist could come in and onboard very quickly and train models which were available in open source or as well as any custom additions they want to add on top of it, and not be dependent on any particular model type. We traditionally had model training and model serving components already at Katakam, but we were particularly tied to model formats, and with guardrails, we kind of evolved from there. And given once we are able to solve the training side of things, serving was in itself a different beast to handle, because you want to support different conditions when it comes to serving, like your latency, compliance, safety, and apart from this, being able to serve models in a model agnostic and framework agnostic fashion. So in this talk, I would like to focus more on serving and what was our journey with serving with respect to Kubernetes. So we started initially with a sidecar pattern and eventually moved to Kubernetes-native patterns to kind of evolve from here. So yeah, we all have a question on why we utilize sidecars. So our immediate need at that point was we want to support and verify that all these different guardrails that we were building actually can cohesively work with our generative AI use cases. And we wanted to launch the MVP very, very quick. So the priority for us was to test out the entire framework end-to-end and see that it cohesively works out. So given this perspective, sidecars fit well to quickly test your framework because, one, the way we set up sidecar is the main pod has the business logic, which mostly is in TypeScript world, and every sidecar, we utilized model serving layers inside the sidecars in Python. So we were able to, first of all, separate the business logic, and we were able to achieve both latency and security because when you utilize sidecars, your communication is basically local host, so you achieve a good latency there. And apart from that, sidecars are usually cut off from external endpoint communication, so you kind of get your security component as well. So given this, we were very fast to kind of evaluate our structure, go quick to market, and figure out cohesively this entire setup works for us. And now what happened from here? Did we kind of solve all the problems we had at that point is what I want to walk you through. So once we had launched a couple of use cases, we quickly saw that there is a need of more guardrails to be put in, and every use case would have different guardrail needs, different traffic needs, and soon when we go to scale from here, we ended up with a lot of challenges by using sidecars. So some of the key challenges here are when you use sidecar, you end up in a world of over-provisioning. So every pod, you would kind of load all your models. And even if some of the models might not be used so heavily, some might be used so heavily. So over-provisioning is one of the key problems we had. And then when you kind of have the same pod for your business logic and sidecars, then whenever you have to make any update to your business logic or to your models, you end up restarting all your pods. So this ended up in a place where it became costly for us to add more guardrails, to add more sidecars, and then also a velocity constraint for us because even though initially we were able to test things out very quick, we quickly came into a world where we were taking longer to kind of evaluate all these different modes and see that our pods work at scale when you keep adding additional models. So apart from this, we also faced issues with debuggability in the sense that it was not easier to debug when you have your business logic and as well as model serving component sitting in the same logging infrastructure. So given this landscape and the issues we were dealing with, we wanted to evolve to a place where we could utilize a Kubernetes-based model serving to solve and address all these challenges. So what we eventually ended up doing from here is we decided to try out a Kubernetes-based model serving and creating a service for every model or a family of models. So whatever issues we were facing with sidecars, we were able to resolve with respect to independent scaling because now every model would scale on its own based on the traffic needs, and we were able to utilize the pods efficiently depending on the needs for that particular model. Apart from this, we were able to reduce the cost because now the pods needed for business logic and the pods needed for ML serving components were different, and we were able to reduce the amount of pods we even needed. And apart from that, we were able to iterate faster, onboard any new model serving layer faster with respect to guardrails. And this also opened up a space for us to see the metrics cohesively and clearly with a separation of logic behind business and your model serving layers. So given this landscape, we were already in a place where we were kind of model framework agnostic. And once we were able to achieve this, it was easy for us to go to cloud agnostic infrastructure from here. And to put a perspective of where we eventually landed was, this is our overall platform context. So the CY use case, which Raj walked you through all, is actually powered by Intuit's GenOS. It's Intuit's internal generative AI operating system. And our main contribution here is we were able to develop guardrails, custom guardrails, as well as utilize some open source guardrails, host them quickly in a framework agnostic fashion. And also, when it comes to Intuit's infrastructure, we have something called GenSRF, which is Intuit's GenOS safety framework. And we were able to migrate some of our guardrails from a Kubernetes model serving layer to GenSRF, which is heavily reliant on AWS. So here we see that given we followed the Kubernetes pattern, it helped us move quickly into a cloud agnostic infrastructure as well. So relying on Kubernetes helped us traverse the space and navigate very easily and test out things very easy. So given this, I would like to leave you all with the lessons learned in our journey throughout and any food for thought you might have there. So the first one is Kubernetes acted as a universal ML platform for us. So we were in a space where we had a multi-cloud reality in the picture, where we had AWS in the picture, Vertex AI built in the picture, we had self-hosted Kubernetes clusters in the picture. So given this landscape, building on Kubeflow and utilizing Kubernetes-native patterns for your serving layer kind of helped act as universal ML platform for us. And the next one is starting simple and evolve with scale. Yes, we did start with sidecars for model serving layer, but it really helped us launch really quick for MVP and verify that cohesively our system functions well. And we would recommend not to over-engineer, like not to go over-engineer your entire MLOps framework, but evolve it in a fashion where you can move fast with the changing landscape of generative AI. And when the pain point crosses your migration point at some point, that's when we evolve to going from sidecars to Kubernetes-based services to managed platform. And the next one is separate concerns ruthlessly. So separating your business logic with respect to model inference helped us keep things at scale and also move fast at scale. So we recommend not to integrate any ML serving component inside the business logic layer. And the next one we wanted to leave you with is generative AI is a little different from traditional ML, and it brings a lot of requirements. One of the key requirements is in generative AI, every particular request has to go through multiple models. Like every request, you would have to run it through multiple guardrails. So this would mean that some of these guardrails need to be in parallel, some of them could be sequential, and suddenly we are in a landscape where every request has to go through an orchestration or DAG of guardrails. And that in itself brings a lot of cost on how we can achieve this with a sub-second latency requirements to be able to run many guardrails in parallel, and also the compliance and audit requirements we need for GenAI is a lot more than traditional ML systems. So I hope you take these lessons with you and use them in your own framework in some form. And just like I want to leave you with acknowledgement, and just like any other project which requires a village, we would like to thank all our teammates who are part of this journey. And we are happy to take a couple of questions, but otherwise, Raj and I will be in backstage, so feel free to drop by. Thank you.